Now that you're familiar with some of our vocabulary like variations, alleles, genotypes, phenotypes, dominance, recessive, we're going to look a little bit at how we predict the genotypes and phenotypes of offspring. And we're going to use our finches as our example. And so we're going to pretend that here are our parent generation. So here's our parents. And we're going to pretend that we're going to cross them and that they're going to come up with offspring. And we have to determine what is the chance that these offspring end up with short or long beaks. Now, when I'm looking at these two parents to start with, I can see that one has a short beak. And since I know that short is recessive, I already know what the genotype for this bird is. It's going to be little b, because the only way to show a short beak is if you have two short beak alleles. Now the problem with the other parent is that there is a long beak. So I know for sure that there is a big B, but I don't know what the second allele is. So I don't know if it's big B, and we're just masking the effects of the recessive allele, or if it's big B, and I have just two dominant alleles. So in this case, I'm going to share with you that this long-beaked finch is a heterozygote. And heterozygous means that you have one of each allele. So I've got a big B and I've got a little b and end up with a long beak. So what are the chances that these parents have short-beaked or long-beaked babies? The first thing I have to do is I have to look at what are the potential gametes for these. So this bird right here has two potential gametes. This bird is either going to pass on a little b or it's going to pass on a little b. So it's either going to pass on this allele or it's going to pass on that second allele. One of those two. In this case, they're the same, but for this other bird right here, the one with a long beak, this one is different. So this one has two possibilities. It's either going to pass on that big B or it's going to pass on its little b. So remember, your parents or the parent birds only get to pass on one of its alleles. So that's what we do in the Punnett square. Is the first thing we do is we determine what are the possible egg or sperm, what allele could they be carrying? And so we'll say that the mom bird in this case had the short beak and the dad bird had the long beak. But in this case, the mom can only pass on a little b because that's all she has. And she's only going to pass on one because you only get one of each gene from each parent. And then the dad is either going to pass on its big B or its little b. So then what we do is that we see what happens if those gametes were to meet. So if this egg and this sperm were to meet, it would be big B, little b. We always write the big letter first. If instead this sperm were to meet up with this egg, it would be big B, little b. But that's not my only combination. This egg right here could have instead met up with this sperm, and that's going to make a little b offspring, or maybe it was this egg and this sperm, and that would still be little b. So here are all my possible offspring variations based off of the gametes that these parents can make. So I've got 50% of them can be big B, little b, so 50% can be heterozygote or heterozygous, right? And that's its genotype. 50% are going to be little b, so homozygous recessive. Or if I'm talking about phenotypes, it looks like 50% of them are going to come out with a long beak, and 50% of them are going to have a short beak. You could also say 2 out of 4 of them, right? That's the same as 50%. That's just more of a ratio as opposed to a percentage. It's another way to represent the same information. So let's do another example. Here we have parents again, and they both have long beaks, and we're going to pretend that they're both heterozygous. So they're both big B, little b's. So what are the potential gametes for this first bird, we're going to say that that bird can either pass on a big B or that bird can pass on a little b. Then we're going to look at this bird and see what they could possibly pass on. And again, they can either pass on a big B or they can pass on a little b. And then I'm going to see what the offspring will potentially look like depending on the combination of gametes. So again, if these two come together, it's going to be big B, big B. If this one and this one come together, it's going to be big B, little b. This one's going to be big B, little b, and this one is little b, little b. So again, I'm looking at where they combine. And this gives me all of the different combination possibilities. So in this particular case, I'll write it in ratio format this time. If I'm looking at genotypes, 1 out of 4 of them are going to be homozygous dominant. 2 out of 4 of them are going to be heterozygous. And 1 out of 4 is going to be homozygous recessive. Sometimes you'll see people write this as a 1 to 2 to 1 ratio. So you could write this like this, and it tells us the same thing. The phenotypes in this case are a little bit different. So if I'm looking at phenotypes, anybody with a big B is going to have a long beak. So that means that 3 out of 4 of them have a long beak. And only 1 out of 4 of them have a short beak. So I could write that ratio as a 3 to 1. 3 to 1 of them have a big beak as opposed to a short beak. All right, so that's just another way to write the same information. So we'll do this one more time. In this case, we have 2 short-beaked parents. And we're going to say that because they're short-beaked parents, we already know that it's little b, and little b, little b. So all of the gametes, so the gametes here, you could pass on either this little b or this little b. For the other parent, which we write on this side, it's either going to be little b or little b. And then all of the possible gametes are also going to be little b, little b. So that means that 100% are going to be little b, or homozygous recessive. And 100% of them will have a short beak. Okay, so we'll do some more practice in class.